I am Marc Cohn. I'm with Ciena Corporation. I also chair the Market Education Committee within the Open Networking Foundation. And I've actually also been a delegate for the Network Function Virtualization Industry Specification Group through ETSI. So I'm representing Ciena in that activity as well. So I've been involved in SDN for quite a long time, as well as NFV. And the topic of my talk today is to take the architecture and the concepts and start looking at how we can leverage some of the implementation specifically around OpenDaylight. And what I want to cover today is, first I want to just say a little bit about Ciena for those of you who are not familiar with our company. I want to talk about market trends that are leading to the transformation and disruptive change that SDN and network function virtualization represent in the carrier community. And I say carrier, but I really should say network operators, because I think that telecommunications is evolving beyond just strict large incumbent carriers into cable and the alternative providers and other service providers who are actually getting into the business and changing the business quite dramatically. I then want to talk about what some of the drivers are behind software-defined networking in the carrier community, and then launch into a little more detailed discussion on the requirements for an SDN control layer and controller, and I'll make that distinction a little bit later, and then talk about why we are interested and excited about OpenDaylight, and then touch upon the research and development status that Ciena has underway in software-defined networking, and I'll talk about our recently operational test bed that we are excited about as well. So Ciena is a leading supplier in telecommunications infrastructure equipment. However, it's really from the metro to the core for those of you in the carrier space, or in other words, behind all the access equipment. And we're the #1 provider of carrier Ethernet in this space. Our heritage is in optical technologies. So we're the leading provider of long-haul WDM, or wavelength division multiplex systems, and have had a very significant run more recently to try to serve the bandwidth needs in the 100 gigabit space. And more recently, we've been elevating our packet optical platforms, where optics and networking are really converging, or at least IP networking is really converging around dealing with the new IP world for carriers, which actually isn't so new. It's been actually happening over a number of years. And on that note, what we see is the nature of connectivity is really changing. So why are we here? Why are we looking at software-defined networking, and why are our customers looking at that? And it's primarily because the connectivity models that the carriers and the operators who've been providing telecommunications services is really changing. From in the old days connecting hosts, I think we're well beyond that, to connecting people, to now connecting machines, which is where we're going. Virtual machines, and then in the future, IoT, or Internet of Things, which is also starting to emerge. And in addition, there's been a proliferation of over-the-top services, a number of different service providers who are leveraging the telecommunications infrastructure to create new business models and deliver new services. And that's also changing the way that the traditional network operators and carriers and some of the new generation service providers are actually addressing the business. And then there's this, what we refer to loosely as the zone of service uncertainty, but this idea of any time, any device, anywhere access to the content and information that we use for business and for leisure as well. And what is really unfolding because of some of the technological developments, including the cloud and mobility, which you've heard about in the last 2 days. I've heard several references to it, what we're seeing is a tremendous growth in the capacity that's going to be consumed to be able to keep up. I mean, now that when we look at a perfect example is looking at the search market, and when we see that YouTube is the #2 search engine at least in North America, which means that instead of looking at YouTube as a source of video, I think the community is looking at it as a search engine, and that means that the amount of video that's being transported is especially in the mobile network is just exploding. And the kinds of numbers we're seeing are thousands of percent increase over the last number of years, not hundreds of percent increase. So that's one of the key drivers behind SDN. And this is not a real talk to get into all the drivers behind it, but what I wanted to do is look specifically at what were some of the expectations for SDN that major operators and carriers have. And if you look at this chart, and I'm sorry it's a little difficult to read, I extracted some market data from a survey that Infinetics provided. They polled, I think it was 27 of the world's largest carriers. So this is really biased to the largest operators. And what they're really looking for SDN is no surprise. #1 on the list, create new services quickly. This whole idea of agility, which is really driving SDN. And then if we look at optimize the network, simplify provisioning, these are themes we've heard throughout this conference, and for that matter, any SDN conference that at least I've been to over the last couple of years. These are the kinds of themes. So the carriers and the operators are really no different than those in the data center and even some of the larger enterprises that are starting to plan and think about software-defined networking and how it's going to transform their architecture. So we look at some of the use cases more specifically, and I circled a few because they're of particular interest to Ciena. Optical transport, #1 on the list. And that's really curious because if we look at the leading standards body for software-defined networking, the ONF, optical transport isn't quite supported yet. We have a major initiative underway to extend OpenFlow to support so-called layer 0 and 1 devices, but it's not there yet, and this is high on the carrier's list. Inter-data center connectivity, that cannot be a surprise with the advent of the cloud. Clearly, it's important to be able to provide additional flexibility and to be able to optimize inter-data center connectivity with the just complete upheaval in how content is going to be delivered to customers. And then if we look at some of the other ones, within the data center, no surprise there. And it turns out that many of the large operators are operators of data centers as well. They're providing content delivery networks. They have huge data centers for their own purposes. They're certainly not immune to what's happening in hyperscale data centers as well as cloud data centers on top of that. And then if we get into mobility, I think there was a talk, and I know Christoph Kolias, who is one of the keynote speakers, mentioned how mobility is also going to be affected by SDN. We had an Ericsson keynote speaker as well. Clearly, mobility is going to be one of those areas that's going to benefit from the transformation. And then metro aggregation, again, being able to collect all this information, packet, video, and multimedia and otherwise, and be able to handle it in a very efficient way, and be able to do it under different kinds of constraints that we've had to address, at least in the carrier space, over in the past. So again, there's major trends that are driving SDN, and what I want to do now is just touch upon some of the requirements that we're seeing for the control layer. I mean, first of all, we're seeing the need for agility, and these are at the systems level. Openness, simplification. If you talk to most large operators, these come up high on their list. The survey information that I shared with you a little bit earlier confirms that, and reality confirms that. If we look at the platform, high availability. We need a policy-based mechanism to allow us to, in essence, control communications and connectivity. We need programmability, really key. Scalability, security, And then, of course, in the implementation domain, we need to be able to provide abstraction, a distributed implementation of the control layer, or in other words, some type of clustering of the controllers that actually implement that control layer. Hybrid operation in the sense of being able to operate in a SDN world as well as being able to support existing protocols as well, not to mention legacy services that in the carrier timetable are going to span many years, if not decades, versus the way that commercial enterprise moves, even though in a lot of large enterprise we see the same kinds of properties, technologies that live on for quite a long time because of the difficulty and more importantly, the cost of being able to transform them. We need to be able to manage this infrastructure in a way that's consistent with the way carriers and operators like to manage their networks. And then a key technology, and again, don't need to say much more about this to this group, is virtualization. However, the data point is that it is pretty new to the carriers in some respects. It's not that their entire infrastructure is virtualized the way we're seeing data centers adopt virtualization, and some of certainly the largest ones in the world. So one of the things before we get too far is I wanted to talk about the difference between SDN and an SDN controller and a network management system. The network management systems and network management approaches that carriers are used to deploying. And this is quite a long list because we wanted to at least present at least a view to continue to rationalize why a new architecture is needed and why we're going to be driving a complete change up and down the organization from operations to the way in which carriers and operators are going to engage with their customers with SDN. I mean, the first difference is the goal. The goal of the SDN controller and SDN in general is to enable programmability. I mean, we hear a lot about separating control and data plane, which, again, is an important aspect. We hear about abstraction, being able to enable applications to communicate with the network in a clean way that makes it easier to port those applications to different environments. But the bottom line is that one of the main reasons we're looking at SDN is to enable programmability in every aspect. But in the case of network management, if we look at what the goal of management is, it's really to provide FCAPs, or fault configuration, accounting, performance, and security into the network. So again, it's a very different mindset, which is to be able to look at operations around what's there today, what we can tweak, what we can look at, versus we want to be able to change the behavior of the network and do it at a high level. The control model varies as well. It's assumed that, software-defined network is really about logically centralizing intelligence. That's a key aspect of the SDN architecture, as opposed to management systems, which are more built around an embedded model. And you think of the autonomous system model of the internet, where nodes make decisions and protocols are really built around individual devices making decisions around what their configuration and state and behavior might be. And they have very little awareness of what's happening in the rest of the network. Now, this is a general statement in the sense that in the carrier network, there are some logically centralized systems. If we look at the voice network as an example, it's a good example of a logically centralized and controlled system. But it's a very different model for in the data world, or at least in the packet world. The connectivity differs as well. SDN is about flows. It's about end-to-end connectivity. It's about services. Whereas in the traditional management or the traditional environment, the carriers are really providing connections, static connections versus the more dynamic flows. It's a major fundamental difference. Connections might just stem for segments of the network. They're not really an end-to-end concept until you get very, very high up in the hierarchy and awareness. It's really about connecting devices, connecting physical constructs, And it's a different model than this flow-based model that's really up-leveled to where services are being delivered. The operations model is different as well. I mean, SDN is all about automation, and that's one of the key aspects and attributes of programmability. Once we're able to offer programmability, then we're able to come back and use that intelligence to automate the network. And by automating the network, we can streamline operations and we can eliminate some of the manual configuration errors that are characteristic of traditional management systems. If we think about those management systems, today they're very manually oriented. There may be a network management console that provides some level of automation to be able to do some tasks because of the complexity of these devices. But by and large, we're still talking about going into individual devices, creating configurations, going in and monitoring things manually when things go wrong. The CLI is not dead by any means in this community. And even the element management systems are really not end-to-end by any stretch. They're going to be looking at individual pieces of equipment or maybe groups of equipment that are typically provided by a single vendor. And this is one of the reasons why carriers are really especially interested in software-defined networking. The object model in management or in the SDN is quite a bit different as well. And I would argue it's at the service layer. It's a service-oriented model. The notion of users and services and applications don't really exist in traditional management systems, which are much more about ports and even VLANs and other network, device-specific constructs, as opposed to the notion that we're providing applications and services to the end user community who are actually benefiting from these capabilities. The device model is also different. Or in other words, when we actually interact between the controller and a device through OpenFlow, we're not just configuring the device, we're actually changing the behavior of that device based on a number of different parameters. And we have the ability to be able to do things that were really unthinkable before we had a programmatic interface. Whereas in the traditional management environment, a network manager is actually really about two things: configuration and monitoring. Certainly there's some variations, but it's really about tweaking what's already there, not opening the possibilities to run software to create a new network behavior that might be very different for different instances that are of that identical device or different applications for that particular technology. The southbound protocols obviously are going to be different. I mean, we are looking at OpenFlow as at least the first SDN standard, the standard southbound interface that's designed for programmability in the SDN environment, and clearly there will be others, as we've been seeing in the last 2 days. But in the management environment, we're looking at different types of interfaces. They're really built around management, things like SNMP or traditionally TL1, Transaction Language 1, from the Belcore days in the past. NetConf is more recent, but still provides configurability, and it's a management interface. And there's many others. And if we look at some of the advantages of the SDN environment and the controller implementation approach, we've already discussed them. Agility, flexibility, this idea of being able to provide intelligence that we can, by programming the infrastructure, by allowing us to run different types of software to add different capabilities, and be able to do that under a common platform. Whereas in the management environment, the advantage is really the fact that operations over decades has really been built around this paradigm. And it may be somewhat inefficient, but operators, individuals have made careers out of being experts on infrastructure because of the complexities of networks, especially at carrier scale, where we're talking about huge networks, thousands of switches, thousands of devices, and many different types of technologies. What are some of the drawbacks? Well, SDN, one of the major drawbacks that there's a lot of discussion around, or increasing amount, certainly in the carrier community, is the organizational impact. It's not just about technology here. It's going to be about changing the momentum of large organizations and being able to redeploy individuals and make them cross the boundary between software and networking, which is really two separate disciplines and organizations. And this reminds me a lot, and I'm sure some of you, if you remember back to the 2000s, the early, the late 1990s, the go-go days in telecommunications and technology in general, where we were talking about this strange technology called IP and being able to talk about that in the context of operations that were really geared around telecommunications standards such as SONET and SDH in transport. And it's two completely different worlds. And at the time, we heard more than once that we would never see the day that IP would be taking over our networks. And now you can barely find a mobile backhaul system or any other access system that's not going to be built around carrier Ethernet and other packet switch technologies. In the management world, the major drawbacks is the fact that it's just slow. It takes forever. It takes a long time to be able to turn up new services, to be able to troubleshoot these complex networks. They're built really around human expertise in being able to provide certain limited information to be able to do that versus to be able to have software on top of this network to be able to ensure efficient operations. And then, of course, one of the most important aspects, and this is one of the carrier colleagues who mentioned this one, which is the deployment model. If you think about a management system today, what does it really look like when we look at the overall or providing an end-to-end service? It's not just a single network management system. It's multiple tools that need to be integrated together at some levels. They have different functions, things like performance management versus fault management versus configuration and inventory and auditing versus even providing different management systems for different vendors' equipment. But it's a very involved hierarchy of management capabilities that are really needed to manage an end-to-end service. In the SDN world, we're trying, and the goal and vision is really about unifying the capabilities. The controller provides end-to-end connectivity, end-to-end visibility, and we're able to leverage logically centralized state in the network, whether it's topology, whether it's some asset and inventory information, and be able to provide this higher level of service versus what we see in the traditional carrier network. So with that, I want to talk about one of the aspects of, or one of the key requirements and one of the critical aspects of the SDN architecture that's particularly of importance to major carriers. And on the diagram you see, this should be very familiar. This is the ONF SDN architecture model. We've promoted this quite extensively since 2011, if not before, and it's been brandied about in a lot of different circles. If we look at the top, we have business applications, which we can think of as applications that are using SDN network services residing, in essence, outside of the SDN umbrella. That's really the distinction in the ONF SDN architecture model. What we tried to do is create some precise terminology to avoid the ambiguity of things like applications, which means many things to many people. We have a northbound interface. We heard several, I think at least 2 or 3 sessions on the northbound over the last 2 days that allows applications to be able to access these SDN services. And that northbound interface is provided by the control layer. The control layer is the sort of the logical capabilities that provide the intelligence, the abstraction, and the logically centralized state that makes up the control layer, and it's actually extracted to a large extent from the underlying devices in that infrastructure layer shown below. And this architecture model is really the framework for what Ciena is looking at when we move ahead. Now, if we think about what are the aspects of openness, which is really the purpose of this slide, that are so important to not only carriers but really other operators and others who are considering the SDN architecture as well. I mean, the first thing is we want to provide those common APIs. That northbound may not be completely standardized for the reasons that we've been citing over the last 2 days, but it's certainly going to we want to provide some level of commonality to enable diverse applications access to these SDN services provided by this architecture. I realize it's a little bit abstract. We're going to get a little more detailed in just a minute. And what we want to be able to do is to provide more open service data models as well, which is one of the benefits of being able to support common interfaces. We want an open platform. Another dimension of openness is not just about the interfaces, it's about providing a platform that allows us to run different types of control software within that control layer or within that controller implementation. And I talk about the control layer in a more abstract sense as capabilities, architecturally speaking. I talk about the controller as an implementation of that control layer. And by providing a common framework, we're going to enable multi-vendor software. We're going to be able to abstract those applications, those business applications that are running on top of the SDN architecture, and abstract those from the control intelligence, meaning we can leverage those control algorithms across different applications. And at the same time, the control layer serves to abstract the applications from the underlying devices that are making up that infrastructure layer as well. And then, of course, we want to provide a standard interface to the devices so that we're able to provide for the programmability in a common means and be able to enable OEMs who are creating hardware to be able to develop to a common interface so they can plug into the overall SDN infrastructure. So openness really spans all of the above. Common APIs from above, the ability to run in different types of software in an open platform, and the standard interfaces that are really critical to enabling the vision of software-defined networking. Now, before we go on, I just want to touch upon network functions virtualization. I'm sure most of you are familiar with this. I wanted to just spend a little time talking about why it matters. In today's implementation environment, even for network management systems and for many other software developments that carriers are either driving themselves or they're actually purchasing and licensing products, they are actually requiring virtualization and the benefits thereof to be able to scale, to be able to provide the flexibility, the dynamic behavior, and the ability to be able to recover based on a new initiative that's actually only about a year old. It's about the same age as OpenDaylight when you really look at the organization, called NFV, Network Function Virtualization. The whole NFV value proposition is very similar to the SDN value proposition. It's about agility. It's about resource optimization, recapturing stranded capacity in the various different hardware, and in some cases hardware appliances, other cases dedicated servers that are deploying network software, and then improving operational efficiency. If I put SDN on that slide, it would be the same value proposition. This is an Etsy group. It got started, actually it was in fourth quarter of 2012. There's a typo on this slide. The first meeting of the NFV ISG was in the Etsy headquarters. It was I think it was in January of 2013, and now it is, it's a significant force with 28 operators. There's 150 plus vendors that are involved, and quite a lot of excitement in the industry. And what it represents really is carriers banding together on their own to be able to collaborate so that they can exploit the benefits of shared innovation, shared ideas, and then be able to think about the greater good as opposed to just looking at their own proprietary interests. And there's a recognition that there's 1 + 1 = 3, or the power of the group transcends the interest of any one carrier. And it's one thing if we get some independence involved, but when we start seeing most of the major carriers in the entire world, AT&T, Verizon, Vodafone, France Telecom, NTT, Korea Telecom, China Telecom, you name it, and they're a part of NFE. That's why there's so much excitement. That's why the next meeting that we have next week in Malaga, Spain, is sold out at 250 participants. This is an initiative that's really changing the way carriers are thinking. And we're also going to be responding to that in the SDN architecture, because based on the use cases, and if you recall the presentation that Christos Kolios made a little bit earlier, we see that a lot of those use cases are built on cloud, they're built on dynamic services, and they're going to require a more dynamic network than what we have today. And that's where the relationship of SDN and NFE becomes important. Now, the topic of this presentation was just to share Ciena's individual perspective on SDN and also to illustrate the role of OpenDaylight. This is not at all a sales pitch, but what I wanted to do is to show you the Ciena's open architecture, which is how we refer to SDN, which actually is going to allow us to run different types of applications from the top in the application layer that are going to be, in some cases, cloud-based, in other cases, normal, or at least not over the cloud. We show management. We show OSS, BSS, operational support systems and business support systems, as applications. And that's what they are. They're not fundamentally integrated into the network, but billing systems and ordering systems and inventory management systems are not necessarily network software. The big module in the middle, the control layer, is where OpenDaylight fits. And Ciena is very interested in OpenDaylight and has been exploring and working with some of the different OpenFlow controller technologies over the last couple of years as we've embarked on the journey toward SDN. And as you can see, we actually have network services that are actually embedded into the platform, the framework that OpenDaylight represents. And then on top of that, we have network applications that are actually going to sit on top of what that OpenDaylight framework and provide other kinds of value-added algorithms and capabilities for the network. And I'm going to show a couple of examples that we're considering in another slide. And the idea is to be able to leverage the community and be able to integrate OpenDaylight, or at least at this point we're considering integrating OpenDaylight into the control layer framework, and then be able to devote our resources to higher value-added problems or solutions to the problems that our carriers have, to optimize their network, to streamline their operations, and to be able to enable them new opportunities for driving revenues, which is ultimately the most important benefit of SDN of all, which is to better monetize carrier networks. And then if we look at the bottom, we are going to see standard interfaces, open interfaces for programmability built around OpenFlow, as well as existing interfaces so that we can talk to some of our long-standing products that have been in the field, that are well deployed into large carrier networks, running some of the most sophisticated networks in the world. Those are not going away, so our SDN strategy has to be able to address both existing equipment as well as some of the newer devices and upgrades that are going to be built around SDN. And the only other point I want to make in this slide is that if we look at the architecture and we look at the way the carrier network's changing, at the bottom it's sort of hard to read, but we really have a different mindset in terms of how we're providing connectivity in this overall new landscape that SDN is really spearheading. Instead of just looking at connectivity on a box-to-box level, we're starting to think about it in terms of connecting users to content and content to content. And those are driving decisions that are being made for how we're going to deploy SDN in the various different segments of carrier networks. It's also going to influence the migration from where we are today to the SDN world, at least in terms of some of the specific applications that are being considered. It's a very different model than where we are in the past, and it's a model that's long overdue given the benefits. In this slide, I wanted to, again, very familiar slide that's been adapted with various different things missing, things added. I just wanted to touch upon what our thoughts are on OpenDaylight adoption. And Ciena, again, is very interested in OpenDaylight. We've been beginning to contribute. Some of my colleagues who are based in San Jose, by the way, given the company has operations in a number of sites, but there's a group in San Jose that's very interested in OpenDaylight and is starting to contribute in the community. Some of the blocks in red are some areas that we're particularly interested in, and we're thinking about making contributions in various different areas. We've already started, and that's going to continue and accelerate. The other blocks in red are things that we're going to be developing in particular. Things like carrier interfaces that we're going to actually provide plugins to the SAL for things like TL1 or Corba, which are how we talk to existing legacy network devices. Actually, not even legacy, but just existing network devices. And then at the same time, we are going to be looking very hard at some of the network services that are provided in OpenDaylight, and then being able to adapt those for deployment within carrier environments, which may be different than some of the existing services that are actually deployed in the data center environment. And then, of course, network applications on the top. We're going to be looking very hard at those. Those are the opportunities that we see for leveraging SDN. We intend to use the OpenFlow plugin as well, and we intend to be looking at OpenFlow as a longer-term solution as we start to migrate carriers from the world that they live in today into this model. And then, of course, we're going to need to integrate into the management framework as well. So again, Ciena's intent is to become much more involved in OpenDaylight. I have also been asked to participate a little more in the OpenDaylight community. Obviously, I'm coming at it from a marketing and product management perspective, so I'm looking at the marketing side, but I think there's opportunities to contribute throughout the community. So we talk about some of the network apps, and this is, again, this is the value proposition behind software-defined networking. It's really about programmability. It's about providing new capabilities and enabling our customers with the benefits of different ways of thinking about problems and solving problems than the capabilities of the previous generation network allowed. And what are some of the applications we're considering? I just want to give you a couple that we're thinking about. vWAN, which is it's actually a product that's not available on OpenFlow today, but that's clearly our intent. It provides network resource scheduling and brokerage. It allows us to be able to virtualize WAN connectivity between the data centers, typically in a cloud environment, and to be able to provide and enable bandwidth on-demand services. It's a good example of the potential for not only OpenDaylight, but the overall SDN architecture, being able to virtualize, being able to maintain multi-tenancy, being able to provide for a much more optimized set of, or optimized approach to arguably the most expensive bandwidth in the overall network, which is the WAN bandwidth. Multi-layer is another area that Ciena has long been involved. This is the idea that instead of trying to manage and optimize topologies at individual layers, whether it's optical, whether it's Ethernet, or whether it's even at the routing layer with OTN in between in layer 1, what we want to do is to optimize connectivity across the layers. So we want to be able to look at the connectivity request and then being able to offer different capabilities or at least path selection based on an integrated view across the layers. Again, leveraging the logically centralized state that we're going to maintain within the control environment. So we're looking, we do this today in some of our existing core carrier products. We want to be able to leverage and extend that model into the SDN world. So we're looking at that as another potential area. And if we do that, And if we look at the dynamic SDN environment, what's going to happen is that we're going to be placing services and removing services because, again, we're looking at a more dynamic environment. So what we need to be able to do is at some point go back and, in essence, the analogy would be defragment the network, or in other words, be able to look at the deployment at some periodic interval and then be able to re-optimize to ensure that we can actually offer the greatest amount of capacity for those investments that carriers have made in their networks. So we call that multi-layer optimization. Another concept that we do today with existing networks, we're trying to examine this in the SDN environment as well. And then dynamic pricing, and this is the idea of being able to not only optimize resource utilization, but optimize revenues based on supply and demand in real time. And I got another slide that discusses that particular use case. So some of the use cases that would leverage some of the capabilities that we're considering, that we've actually been involved in for quite a long time, that we're thinking about as targets for SDN deployment, again, in conjunction with our key customers. Bandwidth on demand. Again, being able to provide for dynamic capability as needed, short-lived connectivity, and then being able to provide different types of policies based on the needs of our particular customers. Data center interconnect for cloud cloud interconnection. It's an obvious one. It's what some of those who are actually providing SDN services like Google or NTT are already thinking about, which is to be able to provide much more efficient interconnections of data centers in this new cloud environment. And then, again, another target use case is to be able to look at our existing transport networks today and determine how we could apply multi-layer control and optimization within the existing transport network. So again, these are some of the use cases we've been discussing with our key carriers. You saw the list earlier provided by Infinetics. There's many, many applications for SDN. There's not just one, and it's not even clear that there's one predominant one at this point in time. Depending on who we speak with, we see a very different view. So what I wanted to do is just put things together a little bit. If we had an ability to provide intelligence, and we were actually developing some of the applications that we talked about, this is just an example of how we might change the carrier world by allowing carriers to optimize revenue within their networks using a dynamic pricing model. And the idea is to be able to allow an enterprise to make a request, and that request would actually allow that operator to specify the needs of that connectivity. And this would be things like what is the bandwidth, what's some of the policy, is it protected, meaning is there an availability requirement for that particular connectivity, and other related parameters. The other thing we would like to do is to be able to offer a schedule. So in other words, the notion that we make a request and it has to be done right now, that can be relaxed, and it may very well be beneficial to relax that demand given what else is happening on the network. And this is sort of analogous, if you think about it, to online airline reservations, where you have this little option, check if you're flexible, and it gives you the flights within 3 days versus the very specific dates that you select. And you know where this is going. When you have more flexibility, you might pay less as well. And that's exactly where we want to take this. So what we're going to do is, with our real-time analytics engine, we're going to look at supply and demand, and we're going to make offers to our customers based on the specific and real-time capabilities and capacity that's available at this instant and in the future. And the idea is to be able to smooth out the peaks, improve the overall utilization by incentivizing customers to fit into the available capacity that carriers are offering. Now, to do this without software-defined networking, without dynamic connections, this would be really, it would be very, very difficult to execute. It would require a lot of over-provisioning, a lot of static provisioning. It would require some monitoring that would not be real time, but would have to make some simplifying assumptions. It would be very, very difficult to be able to implement this in the confines of today's carrier network. And that's really the point of this exercise. So what I wanted to do now is, Ciena has not yet at least not yet announced our SDN product strategy. We certainly signaled our intentions if you've seen any of our announcements over the last number of months. But the one thing we have done is we've actually created an SDN, an OpenFlow-based SDN testbed in conjunction with our research and educational partners. And in this diagram, we're seeing a 100 gigabit per second DWDM international network that's just become operational. And this network is going to be providing Starlight in Chicago and ESNet and Canary in Ottawa and ultimately other partners as well, an ability to be able to try out their big data science applications, research experiments, other such things in a operational 100 gigabit SDN WAN. And the development activity that's driving this, the prototype controller activity that we've developed to date, the OpenFlow embedded agents, which have actually taken to the ONF Plugfest, the interoperability event, multiple times within the last 12 months. All of this is feeding into the product development that you'll hear about later in the year. So with that, I wanted to pause and see if there's any questions, because we do have quite a bit of time. So any questions? Yes, in the back.
Thanks for sharing this slides and this strategy. Do you see the display in a multi-vendor environment, or should we just see it?
That's an excellent question. The question was, do we see the concept in a multi-vendor environment, or is it a Ciena-only environment? Ciena has made a strong statement to the market that we are embracing openness, expansive openness, which is why I actually singled out the slide that touched upon what does openness mean. Providing open APIs to enable different applications to communicate and utilize the services that we're providing. An open platform so that Ciena and non-Ciena network applications and services can actually reside within that platform. Not to mention the open interface, which is OpenFlow, to the actual devices themselves. So we are strongly embracing openness, and we are going to be driven by our key customers who are already outspoken about what they are expecting in their next generation network deployments and plans for software-defined networking. Great. Yes,
Mark,
Carol.
Is Ciena involved in any of the proofs of concept with the NFV group?
Carol's question was, is Ciena involved with any of the proof of concepts, the POCs, in the ETSI NFV group? The answer is no. We've been thinking about that. If you think about NFV and the platform, a lot of it is really around the compute domain versus the network domain. So Ciena has been observing. We've been tracking activities within NFV. But again, if we think about the activities over the last year, since the NFV initiative has actually got underway, most of it is around how do we create a hypervisor, the management and orchestration, how the NFV infrastructure talks to management, talks to, the software resides in there. It's not really about some of the things we've been talking about, the relatively low layer. But Ciena is open if there's an opportunity, especially as the NFV matures, that we could potentially participate in a proof of concept. Yes, I'll take that, and then Chuck, I'll get to you in a minute. This testbed is not using OpenDaylight. The prototype controller that we developed for this testbed was built on Floodlight. We started working on it quite a long time ago, and it was developed again, so that we had opportunity to get some things out, to be able to develop internally. And OpenDaylight, again, has come along in a very, very rapid timescale, and when we talk a little bit more about where we're going, OpenDaylight is certainly high among the considerations that we have for our control layer plans. Okay, Chuck?
Well, I think you kind of answered the question, but the previous architectural slide showed the controller being OpenDaylight, and I wondered, and certainly that would be required if you're building,
This slide?
one after that, actually. Well, that one shows OpenDaylight too, but this one shows that you'd be building potentially TL1 and Corba plugins, which would be possible with OpenDaylight, but not with other standard only controllers. I wondered what state are you guys at in terms of determining which controller you're going to go with?
Okay, Chuck's question was, and I think I'll mention for anybody who can't hear, what state of our considerations is Ciena in regarding the selection of a controller? Well, again, Chuck, first of all, again, like I mentioned, we haven't announced our product plans, so I want to couch that in terms of where we are today. We've been very active in the community looking at the various different controller options that exist today, and want to understand this development status, the capabilities, the differences, the implementation considerations for a number of different possibilities. We are excited about OpenDaylight because of the community, because of the opportunity to be able to leverage hundreds of developers and all the benefits we've heard about over the last 2 days. That being said, we have not yet at least committed our intentions publicly as to which way we're going to go. But OpenDaylight is certainly one of the strong contenders for the control layer platform for our future plans. So other questions? I think we have a few more minutes. I know everybody wants to get to lunch, but thank you. Go ahead.
So, like in this slide, you showed TL1 and Corba. So, if you look at in the transport word, TL1 is a protocol of choice. Do you see you working with other vendors, or does it be specific for Ciena?
Well, again, that's a really good question. The question is that the OpenDaylight adoption slide shows TL1 and Corba plugins into the SAL, into OpenDaylight. And the question is that, if I can rephrase, is that specific to Ciena, or is that something we would work with other vendors? And I think that Ciena would be open to working with other vendors. The caveat is that we have TL1 and Corba interfaces to some of our existing products. So obviously, as an OEM, our interest is going to be to ensure that those plugins are going to be compatible with our products at a minimum. But there's nothing to say that we couldn't try to serve the interest of others as well. That's the mantra of the open source community. That's the decision we made by embracing expansive openness, is that it is going to be a multi-vendor world. That's not and by the way, that's our customers talking. That's not necessarily driven completely by our altruistic intentions. It's really because the world is changing, and Ciena, it wants to be on the side of doing the right thing and moving into the openness world today versus being drug in, resisting at every turn, and then locking it, continuing to cause our customers difficulties as they begin to embrace and adopt SDN. Yes, Chuck?
Yeah, sure. So for your open flow support, are you targeting a particular version like 1.3 that supports PVD, or maybe a future version because of the optical?
Well, yeah, that's an excellent point. Chuck's question was, what version of OpenFlow are we targeting for this, especially considering the specific needs that we have for optical transport, which is not currently supported in OpenFlow, or at least 1.3, which is the current release that industry is gathering around. Our intentions are to we are all on a long SDN journey. We recognize that. The carriers are not expecting to be able to go off and change their networks overnight. There is no, the optical transport extensions that you're referring to, and for those of you who are not aware, the ONF has a working group that's actually specifically looking at how we can extend OpenFlow for optical transport, and actually, as an aside, for that matter, mobile wireless applications as well. Those recommendations are expected around mid-year, if not before, and then we will make decisions within the ONF as to which release of the OpenFlow specification those extensions will be implemented in. And once those are implemented, you can bet that Ciena is going to have a major role. And it turns out Ciena, my colleague who's based here in locally, Lyndon Ong, it actually chairs the optical transport working group. So Ciena is very heavily involved in those discussions as well, as are many other vendors who are part of the ONF. So other questions? I think we got, again, a couple more minutes. I don't want to hold anybody up from lunch, though, so feel free. All right. Well, in that case, then I want to thank you for your time and thank you for attending, and stay tuned for details.